see about the analytical ultracentrifuge. Analytical ultracentrifuge is a important centrifugation technique. As we already saw, a centrifugation can be divided as based on its technique, as based on its sample separation, as preparative ultracentrifuge and analytical ultracentrifuge. In this video, we are going to see about analytical ultracentrifuge. A major principle involved in analytical ultracentrifuge is identification of characteristics of sample, where it involves identification of characteristic of sample. Therefore, it performs both qualitative and quantitative separation or centrifugation or sedimentation of a compound, and we can also find quality and quantity of a compound. Thus, analytical ultracentrifuge is going to provide a more pure sedimentation or more purest of compound to be separated off. It needs high speed motors. As it was high speed motors are involved, it lead to production of heat. This heat may cause us a denaturation of biological components. So, to overcome this heat, a refrigeration system can be used, and an evacuated system can also be provided in the analytical ultracentrifuge. This evacuated system is very important to decrease the friction of compound. So, by decreasing the friction of compound, it lead to decreasing the viscosity of sample and the medium. By decreasing the viscosity and decreasing the friction, it lead to increased sedimentation. Therefore, the compound to be separated is going to be more pure. So, the evacuated system is used to decrease the friction, thereby increases the sedimentation of a component with highest purity. So, the instruments to be used for building up the analytical ultracentrifuge is going to be rotors. As we already saw, every centrifuge needs to have a rotor. So, here the rotor is going to be in the form of elliptical shape, as a rotor must have a region for holding of the test tube. So, this rotor to have two holes. So, the one hole is going to have analytical cell, another hole is going to have a counterpoise cell. So, the one hole which has a analytical cell is going to be in the form of sector shape. So, this it's going to hold the sample. Analytical cell is going to hold the sample. So, the holding of sample of this analytical cell is going to have 14 mm height, and capacity of this sample holder is going to be 1 centimeter cube, and another is going to be a counterpoise cell, which is going to balance the analytical cell weight. So, the counterpoise cell is going to involve in balancing of the cell, and there is also a window where here analytical ultracentrifuge is going to involve in identifying the characteristics of the sample. To identify the characteristics of a sample, where there is a colorimetry similar principle is going to be followed. For that, there will be a source of light. A source of light is going to pass its ray to the cell. For that, a window, a opening in the analytical cell is provided. Well, it's going to be involved in the evacuated system. So, this window is very important for the passage of the rays from the source. So, the upper and lower planes are found in the analytical cell, which is going to be transparent with the quartz and sapphire window. So, the quartz and sapphire window is going to be involved in the evacuated system and very efficient in involved in passage of rays to the analytical cell. So, it involved in passage of rays. Next, evacuated chamber. As the analytical ultracentrifuge is going to decrease the friction and increase the purity, it leads to production of evacuated chamber, which is going to provide the vacuum for about 1 to 2 mu m. It involves in reducing the friction in the sample, thereby decreasing the viscosity. Decreasing the viscosity lead to increasing the sedimentation of a compound, which lead to increased impurity of a compound. So there is another system to be involved is the optical system. As we already say, analytical ultracentrifuge is going to be involved in the identification of its characteristics of the sample. For that, the optical system is used for the identification of characteristics of sample. So the principle to be used here is Rayleigh interference principle. So the Rayleigh interference principle involves passage of rays, and this passage of light is very important for identification of or following of sample separation. To identify whether the sample is separated off completely or incompletely can be identified by Rayleigh interference by passage of rays, and it was going to be onto the analytical cell, and this rays or gets spotted off or imaged of such peak. This peak is very important for identification of quality of the sample, as whether it is separated as incomplete or completely. So it has a passage of light to pass to the analytical cell, and it was then passed into the monitor to identify the progress of centrifugation, to identify whether it is a complete or incomplete. So here the flash of light to be passed is going to be xenon flash lamp, where it is going to pass through the window, that is quartz or sapphire window. The xenon flash lamp as a source is going to provide about 230 nanometer of ray light. So the flash which is going to pass into the analytical cell is going to move on to the monitor, where a result of progress of the centrifugation can be noticed in the form of peaks. So this is going to be an image how the analytical ultracentrifugation is going to be worked off. This is going to be a xenon flash lamp, which is going to provide a 230 nanometer of light rays, which is going to pass through the aperture. So it's going to reach off to the refractive gratings, and it also reach up the reflector through this window. This is going to be a window where a quartz or sapphires can be used. So this is going to be an evacuated system, about 1 to 2 mu m evacuated system. This evacuated system is going to have, this is a counterpoise cell which is going to balance the analytical cell. This is going to be analytical cell, where the rays are going to be passed to it. Then a sample, how it going to be separated off, is going to be noticed through the detector. A detector is going to use this photomultiplier tube, which is going to convert a light into signal in the monitor, so that a progress of centrifugation and the sample characteristics of purity can also be identified through this imaging system. And next important tool to be used is refrigeration system, because a centrifugation is going to be performed at high speed, so the refrigeration is very important. Here a refrigeration is going to be taken place by thermocouple, because a thermocouple is going to convert a heat produced by the motors to cold temperature, so that it is going to deduct the heat which lead to decreases the increases the purity, therefore reduces the heat created a chamber for high speed RPM. As a motor has a RPM of 2,50,000 RPM, which is going to be highest of all centrifugation, as it was going to be ultra centrifuge. It's going to have a RPM of ultra centrifuge. There is going to be a rotor shaft. We are going to study about rotor shaft because a rotor shaft is going to hold of the test tubes, so it must be very strong, as it's going to spin at 2,50,000 RPM. So it's going to be at the calibrated distance from the center of the rotation. So as it was going to be very strong, the rotor shaft must be at aluminum or titanium material or metal. The shaft is going to be 1/16 inches distance. Next, we are going to see about how the result is going to be identified in the monitor as in the form of calibrated graph. As the progress moves down, the peak shows the characteristics of a particle. As when there is more peak, there will be no more purity. When there is a shouldering peaks, then a shouldering peaks lead to decreased purity. So these peaks are get photographed in the monitor. The optical information which is converted into signal in the form of peaks is going to be photographed, and these results are used to monitor the centrifugation process and progress. A main advantage of this centrifugation is going to involve in identification of sedimentation coefficient of each proteins. Because of the peaks, we can identify the characteristics of the compounds like sedimentation coefficient and molecular weight. Where the preparative centrifugation is not possible for identifying the molecular weight, that means a further analysis of a sample is not possible with the preparative centrifugation because it is either used for further preparation, but analytical ultracentrifuge is going to provide a purest compound, so it is used for further analysis like sedimentation coefficient identification and molecular weight identification. It's going to identify the molecular weight of a macromolecule. It is also used for isolation of protein nucleic acid of highest purity. It is very involved in identification of the compounds based on its size, shape of macromolecule. Its highest motto is going to be a component must be more pure. It also involved in detecting the conformation changes as it was identifying the component by optical system and its progress, so for the conformational changes can also be visible through this process. Small and larger contaminants can be identified by shouldering the main peak, so that a components to be separated is going to be of purest or with some contaminants can be identified through this process. So how this molecular weight is going to be identified? We are going to see about that processes. So the molecular weight identification we can see in next video. In the last video, as we see the analytical ultracentrifuge, a major technique to be used for identification, sedimentation of the sample of different components, and also to identify the characteristics of a component which is possible with the analytical ultracentrifuge, which is going to provide a sedimented compound of highest purity. Now we are going to see about methods can be used for identification of a molecular weight of the compound to be used in the analytical ultracentrifuge. So the molecular weight identification is possible by many techniques, but the molecular weight identification after the sedimentation of a compound by analytical cell is very important technique to identify its characteristics. So the molecular weight determination from a smaller sample size of 20 to 120 nanometer to a larger sample size of 0.01 to 1 gram per dm can also be possible by this analytical ultracentrifugation process. So the three methods can be used. First method is going to be sedimentation velocity or boundary sedimentation. Another method is going to be sedimentation equilibrium or band sedimentation. Another is going to be equilibrium. Based on its name itself, we can find its process. First is going to be sedimentation velocity or boundary sedimentation, which means we are going to identify the molecular weight based on its sedimentation velocity. As in the sample, the components of the sample is going to be randomly distributed particles. When the centrifugation starts, as the centrifugation starts, it's lead to movement of particle radially at the first. So here we are going to found the movement of, that is velocity of a particle moved to radially is going to be measured in sedimentation velocity. So it's going to be known as boundary sedimentation because it's going to move radially, which means it is going to move towards boundary of the test tube. So it's going to be identify the movement, that is velocity of a compound between a boundary and the solvent clear. It can be identified as a sedimentation is going to be at the last step, but at the first step itself we can identify how the components are going to be separated off by moving it radially, how much time is going to be taken off, and how its velocity, that is speed or movement, is going to be taken place when it was moving radially during the first step of separation. Here we are going to see about the first step of separation, that is a movement of particle to the radial portion, is going to be analyzed through optics. That means a sclerotic optical system is used as a ray is continuously passed and there is a continuous monitor of progress of the centrifugation. So the first step of centrifugation, that is movement through radially, is used for identification of sedimentation velocity, which can be used to identify the molecular weight. So here we are going to use a gas constant, R value, T is going to be temperature, and sedimentation coefficient. As each component is going to have different sedimentation coefficient, based on it, it's going to be differ. A sedimentation coefficient is going to be a sedimentation to be occurs at the standard temperature of 20 degrees Celsius, and D is going to be diffusion coefficient, because here we are going to see about the movement of the molecule, that is velocity of a molecule that is going to be separated from the solvent at first to move radially. So this movement needs diffusion, as the components of sample are going to be diffused through the solvent. So it's going to be diffusion coefficient, and rho p is going to be the partial specific volume of a macromolecule. So it's going to be volume of a sample to be separated, that is partial volume. Here we are going to see about partial volume because the separation is not completed. During incomplete separation or at the first step of separation, here we are going to identify the sedimentation velocity. Based on its sedimentation velocity and diffusion, we are going to identify the molecular weight. So as we see, M is going to be molecular weight of a macromolecule, yes, R is gas constant, T is Absolute temperature, S is sedimentation coefficient, D is diffusion coefficient, rho is going to be a partial specific value, and V is going to be partial specific value, and rho is going to be a density of a medium. It is a first step. It is not a standard step. Next step is going to be sedimentation equilibrium or band sedimentation. It is a standard and accurate step to be used to identify the molecular weight of proteins. If we find the molecular weight of a protein, it is very important to identify the protein which is separated. So, a sedimentation equilibrium, from the name itself we can identify there will be a equilibrium or band sedimentation. There is a equilibrium or sedimentation equilibrium, which means a sedimentation has reached to equilibrium. A sedimentation is going to be completed. In the before technique, where a sedimentation is incomplete, at the first step of sedimentation we are going to see to identify the molecular weight of a protein. But in this technique, where sedimentation equilibrium, as the sedimentation is going to be based on a completed separation of macromolecule, where here a sedimentation is going to be at equilibrium where band has separated. So a macromolecule is dispersed through the medium to the direction of diffusion. Here the macromolecules has, it's going to be a medium. Macromolecules are here. When the centrifugation starts, these macromolecules are going to move radially. After it move radially, going to disperse off. So a dispersion or diffusion of the macromolecule is accounted here, and the centrifugation is going to be done till a sedimentation and diffusion of a macromolecule has no net movement. That means a compound is completely separated, sedimented. A macromolecule which is completely sedimented means a macromolecule has no further sedimentation movement or no further diffusion movement. So there is no diffusion or no sedimentation. In this process, a sample is completely separated. So this period is taken into account during sedimentation equilibrium. As a sedimentation takes more time, so this process need more time. But in the case of sedimentation technique, before we have saw, it's not going to take more time. It's a shorter time because the sedimentation at the first step, that is a movement of radial itself, we are going to measure. Based on that, we are going to provide the molecular weight. But here we are going to wait till the sedimentation is completed off. It is going to be a popular technique. Then the sedimentation velocity, as it was going to be very accurate. So here there is a formula to be used, is going to be M, which is molecular weight, R is going to be gas constant, T is temperature, and C2 and C1 or the concentrations. Concentration during diffusion and concentration after sedimentation. That means at the start, at the end. These both values can be identified by optic system, where a continuous monitoring of the sample is possible. Then rho is going to be a density and nu is going to be a particle specific volume, and omega is going to be angular velocity to be used in the analytical ultracentrifugation. Another technique can also be used, but it is our most popular, and next technique to be used is going to be equilibrium method. This technique is used when a sedimentation is completed off. But in the case of before technique, where we need C1 and C2, a starting of diffusion and end of a diffusion, that is end of sedimentation, both the values are considered. But here a sedimentation completed value is only needed. That means it is based on two places where the flow of solute is going to be 0 at the meniscus and the bottom of the cell. So the flow of the solute, that is going to be a sample, the flow of a sample at the meniscus and bottom of a cell is going to be considered, as it was based on the principle that the sample can't be moved to either extremities, that is based on Archibald method. Based on Archibald method, as the compound cannot be pushed to both meniscus and the bottom of the cell. So the sedimentation at meniscus and bottom of the cell, the solute diffusion at the meniscus and bottom of the cell is calculated. A major disadvantage in this equilibrium method is it not provides a precise measurement as before sedimentation equilibrium method done. It is going to have less accurate. It's going to provide a wide value which is not provide the accuracy or purity of the compound to identify the molecular weight. So now we have already saw the analytical ultracentrifugation and different types of centrifugation process as above. Thank you. In the next video we will see different topics